last speaker of this session will be Shai Carmiel, the founder of Intelligent Wire, a company that develops and implements deep learning and AI technologies for automatic speech recognition.
That's
Ishai,
fine. Yeah,
yeah.
you can stop with that.
Yeah,
Basically, it's Ishai. So,
otherwise, we'll stay hungry.
So first of all, I want to apologize because I'm going to be the last talk before lunch, and I know that I cannot beat free lunch. I cannot. Oh, okay. So, okay, yeah, because you cannot compete with free lunch. You know, in abroad it's even harder because sometimes you cannot beat alcohol, so it's even harder than that.
Good luck.
Yeah, believe me. So, first of all, I want to apologize because when I was asked to give this talk, I tried to squeeze as much as possible, usually a 6-hour talk, to 20 minutes. And so, but I also want to thank Ziv because he just saved me he showed the panda example already, so I can skip it, so that's good. So if you're thinking about it, AI has evolved a lot. And we see tremendous improvement in speech recognition, computer vision. Oh, yeah, you're making, no, that's not, no, I call this that. No. And we see tremendous improvement in computer vision, machine translation, and as a byproduct of that, we see very, very interesting type of applications like personal assistants. We see a lot of initiatives in autonomous driving cars, and machine translation, for example. I think that Google is processing like 140 billion translation requests per day, so it's pretty amazing. So we are in a very, very interesting era. But the main thing is that also data privacy is evolving a lot. So how many people have heard about GDPR? Oh, good, okay. So I don't need to explain what GDPR means. So, and the Facebook, for example, I'm living in the US, so for example, the Facebook and Cambridge Analytica affair is gaining like so much attention in the US. And if you remember, it actually affected like Facebook stock, it went down by 40% because, some of these things. And more states and more countries are adopting data privacy regulations. So for example, I know that in the state of California is going to adopt a similar a GDPR regulation by 2020, meaning that people are taking user privacy and user data in a very, very serious manner. And if you are thinking about it, there are two questions that arise from that. So the first question is that how can these these things can work together? Because if you are thinking about it, machine learning needs massive amounts of data. And in the post, data privacy prevents us from using this data. So we assume that these things are going to evolve and they're not going to cancel each other. So how can these things work together? And we saw before that is that if people think that AI is the new software, so how can we protect it? And I'm not going just to talk about adversarial attacks, I'm going to talk about a few other things. So the things that I want to cover is what I call privacy and stability of models. How many people have heard about that? One. Okay, that's good. So I have 499 more people that I can explain to. Something that is called machine learning on private data, which is some kind of super cool technique that is involving encryption protocols on machine learning, which is super cool, and adversarial attacks in what I call adversarial data synthesis. And I'm going, because Ziv already gave a talk about it, so I'm going to skip some of this information. I'm not going to touch based on how people are doing adversarial attacks. So the first question that arises is that usually, and I'm working in a company, so a lot of the times we are making sure that our user data, to make sure that we are protecting our user data. So basically we are putting the data in a very secured manner in some kind of a data silos and make sure that only the relevant people can deal with that. And sometimes when we are training data, we can train data on very sensitive data like medical records, social security numbers, credit card numbers. But the main problem is that once we train the model, does the model contain any sensitive information about the data? And one of the things that people are trying to ask is that how can we assess the privacy of a model? Because if you are thinking about AI as the new software, when I'm developing old-fashioned software, I'm calling some kind of an information security specialist to, hey, is my software protected or not? And we don't have these metrics right now, or we have some of these metrics in these new methodologies. So an interesting fact that a few guys from Berkeley created, they were able to train some kind of a language model. You're familiar with language model, right? So they were able to train a language model on data that contains social security numbers and credit card numbers. And surprisingly, they were able, just by asking the model, they were able to reconstruct some of the data. So basically, the model can reveal some of the private information, and they introduced some kind of empirical metric that is called memorization. Basically, how good the memory, the model remembers the data. And this is a very, very serious issue, because basically, if you are thinking about it, even if we protected our data, the model still can reveal the privacy information about the data. And there are some people who are trying to attack that, or trying to assess what type of techniques that we should use. How many people have heard about differential privacy? Okay, because of course, it's information security, so what? So basically, differential privacy is some kind of a methodology to assess how an algorithm is secured. And basically, the basic technique of that is to add some kind of perturbation on top of the data, or some kind of a masking on top of the data, that the statistical properties of the data are preserved, but we are not disclosing single points of the data. So there was some kind of interesting paper that was published in 2016 by Peperno and Ian Goodfellow, which is called, I won't get into the technical details, but it's called Private Aggregation of Feature Ensembles, which is trying to apply differential privacy into neural network models. And if someone is interested, there is a TensorFlow repo for that. There is a very, very good blog post about it. It's a very, very interesting technique, how to assess privacy in models and how to apply differential privacy for models. So the second thing that I want to talk about, and again, I'm sorry if I'm running because due to the time limitation, is something that is called machine learning on private data. And if you're thinking about the machine learning paradigm, there are two aspects that we can think about. One of them is how can we train machine learning models in what you call secured way. And the second problem is how can we do some kind of an inference in a secured way. So let's think about, when you are thinking about training on private data, what type of use case are we talking about? So the first use case is that a lot of the data that we are collecting is what we call is being collected on edge devices. For example, mobile phones, some kind of sensory data, some kind of IoT devices. And a lot of the times, due to data privacy regulations, we want to make sure that the data doesn't go out of the edge device. So the question arises, how can we train some kind of machine learning model when the data cannot go out of the edge device, which seems almost impossible and surreal. And the second problem that we can think about is that how can two parties or multiple parties can create some kind of a mutual machine learning model without sharing the data with each other. So think about two insurance companies. Both of these insurance companies have very, very interesting fraud detection data. And they understand that they can benefit from creating some kind of a mutual machine learning model, but due to privacy regulations, they don't trust each other. They cannot put the data in some kind of a neutral side that will collect all of the data. Can they, or is there a possibility for them to train some kind of a mutual machine learning model? And the third problem is what we call preventing data reconstruction. Can we make sure that the models, even if we use some kind of mumbo-jumbo techniques to do that, can we make sure that the models are secured and we didn't disclose any information? So again, this is a very, very evolving topic. And how many have heard about federated learning? Okay. So if someone is interested, I won't get into the details due to the lack of time. So federated learning is a technique that allows us to train data on edge devices without exporting the data out of the edge devices. Super cool technique, have been developed by Google. There is a implementation in TensorFlow, in the official TensorFlow, so it's really interesting. A lot of these techniques that we are talking about, it's not something new to the information security guys, because these guys were already thinking about how to implement most of these techniques with techniques like secure multi-party, very, very sophisticated encryption protocols. And if you are thinking about it, so basically when I'm, how many have ever heard about secure multi-party computation? Okay, so what is secured multi-party computation, basically? If I'm a party A, and there is a party B, and we want to calculate A plus B, can we do that in a very secured manner without disclosing information? So there is a possibility to do that. There is some kind of security and encryption protocol to do that. And if you're thinking about neural network training, it's basically doing a lot of these computations. So a lot of people are applying secured multi-party computation to neural network training. And the second problem in applying machine learning with private data is, of course, inference on encrypted data. So a lot of the times when we are thinking about inference on encrypted data, we have two parties. One of them holds the data, one of them holds the model, and they don't trust each other. Because first of all, let's assume that I'm a medical institute, I cannot share the data with the model provider. And if I'm some kind of cool startup company, sometimes I don't want to share the model with my clients because it's a very, very valuable IP. So how can these parties work together or create some kind of an inference process? And in order to do that, again, we are talking about very advanced, we are talking about a lot of buzzwords that people are applying today, like multi-party computation or, deep virus encryption protocols like secret sharing, that are trying to apply all of these privacy-preserving and security-preserving algorithms to these type of neural network calculations. So a few other techniques that people are using are like garbled circuits, if you have, two parties. And how many have heard about homomorphic encryption? Okay, so homomorphic encryption doesn't work in that case because it's too slow. But people are thinking that, it's some kind of a holy grail for these type of systems. And there are some solutions that are applying, homomorphic encryption or polyhomomorphic encryption or sometimes fully homomorphic encryption to these type of techniques. And the last thing that I want to talk about is what I call adversarial attacks and deep fakes. So if we're thinking about, if we're thinking about adversarial attacks, so there are two types of attacks. Basically, what we call there are inference attacks and there are training attacks. And when you are thinking about inference attacks, there is what we call the white box attacks, when the attacker has access to the model or some of the model parameters. And there are what we call black box attacks, when the attacker doesn't have any access to the model parameters. So if you are thinking about some kind of an example, I can think about a inference attack that I want to create some kind of a malfunction in some kind of an autonomous car. The second type of attacks, of course, are what we call training phase attacks, when we are trying to alternate the training data, or we are trying to alternate the data collection process that is being done in the data. And there are two types of attacks. One of them is what we call confidentiality and privacy attacks, when you are trying to steal some of the data, some of the information, or some of the confidential information that the data was trained on. And sometimes this is very valuable information, because if you think about it, that if we have a model that was trained on social security numbers or credit card numbers, and I can steal some of this information, this is a very, very vicious attack. And the second type of attack is attack that Ziv was talking about, is what we call integrity and availability of attacks. When we are trying to manipulate the integrity of the neural network or the availability of the neural network. So I was talking a little bit about, already talked about privacy and confidentiality attacks. So if we are talking about integrity attacks, so first of all, here's the famous panda image. So of course, I will skip these slides. So a few things that we are trying to do is modifying the image, and there are multiple types of attacks. One of them is called one-shot attack, which we are doing some kind of single iteration, and there are multiple attacks that are called iterative attacks. And I think that one of the most dangerous attacks is what I call attacks in the physical world. And think about it, this is, for example, an image that a few researchers from Berkeley have done, and they were able to manipulate a neural network that identifies traffic signs. And they're able to do that by just putting some stickers on the stop sign. So if you're thinking about it in terms of the problems that we are thinking about, is that in the what they call the old school cybersecurity space, someone, in order to hack a system, needed some kind of, a non-trivial knowledge in computer science in order to understand what's going on. Right now, every lunatic in San Francisco with a bunch of, with a bunch of stickers can just go and put some stickers on stop signs and just manipulate, how autonomous cars work. The second patch is what it's called adversarial patching, which the researchers from Google put, specific, designed patches to manipulate, neural networks. They call it adversarial patch attacks. I just call it the banana attacks because they were just able to manipulate bananas to neural networks to identify it as a toaster. And I have 2 more minutes. So the last thing that I want to discuss is what I call adversarial data synthesis. And this is truly dangerous. And if you're thinking about it right now with all of these new models, neural networks can really generate data that looks like the real deal. So basically, if back in 2016, we were talking about deep fake and fake news. Right now, we can literally generate, images that look like fake news. We can actually, there are a few companies that can generate voices that sounds like the person. And I don't even want to talk about the vicious things that people can do with that. And this is something that, people are putting a lot of attention to understand how trying to solve these type of things. And DARPA, for example, is creating some kind of a new initiative how to tackle and how to solve deepfakes. People back in November 2018, people were sure that a lot of the presidential Senate election is going to be affected by deepfakes. So these things are really, really dangerous and really, really vicious. And to finalize, because I have like 40 more seconds, we are seeing that there is some kind of a new field that is evolving. And if you're thinking about the classical machine learning where, composed of computer vision, human language understanding, reinforcement learning, and we had the classical information security, which, created, for example, with crypto networks, secure computation, and encryption. And we are seeing that we need to combine these methodologies together in order to tackle the problems in the foreseeable future. So I'm sorry if I did it, in a very, very rapid pace, but I hope that you learned something. So thank you very much.
We have time for maybe 1 or 2 questions. Anyone? Yeah.
Hi. So you were mentioning that there's starting to be adoption of some of these tools like TF Encrypt for TensorFlow and PySift for differential privacy in Python. And I was wondering where do you see the challenges in privacy preserving machine learning before we start to see real adoption in the industry?
So that's a very interesting question. So first of all, the people, so first of all, TF Encrypt is some kind of, it's by Dropout Lab, so it's a little bit, off the shelf. It's not part of, the official TensorFlow repo. But one of the problems, if you're thinking about it, all the papers and all the use cases that people are talking about is, hey, we're able to apply MNIST convolutional neural networks. And if you're putting if I'm putting my machine learning hat, who cares? Because we already solved these problems. So I think that one of the we are going to see some kind of adoption where people will try or will able to solve problems that really care and really are important to the machine learning community. So for example, if I can do some kind of ResNet, secured computation on ResNet 50, for example. Okay.
Okay. Apologies, we have to stop here. So let's thank the speaker again. Thank you very much.